Okay, so we're going to start with Chapter 8 today. One thing I want to mention is that Chapter 8 is a really heavy graphing chapter. Like there's a lot of graphing in it. So if you could please remember to either bring graphing calculator or a phone that has Desmos on it. I think you're Kirsten, what do you have against graphing? She just wrote in the chat, no. It's a lot of graphing and just kind of understanding the graph. Actually, if you look at, well, I don't think I got your notes in your mailbox in time on Monday, but basically we're going to be graphing equations and looking at the domain and range a lot. So if you would like to follow along in class, which I would love, love, love for you guys to do, I would really like it if you could bring a graphing tool. I will have my TI calculator. I have one TI calculator that you guys can share. I got to replace the batteries on that. So that's my kind of intro. All right, so let's get started in Chapter 8. What I am actually going to do is we talked a little bit about 8.1 on Monday, and we're going to talk more about it next Monday because it's a good section to do in class. But what I'm going to do, since we're online and everybody can see my screen and you don't have to have your graphing calculator necessarily, is I want to go over 8.2 and probably 8.3. Yes, I want to go over both of those. So these two sections are called, let me scroll down in the notes since you don't have them, graph simple rational functions and graph general rational functions. So first of all, let's remember what the word rational means. Does anybody remember in math what does rational mean? So remember, it's a number, an irrational number cannot be expressed as a fraction. So when you see the word rational, think of the word ratio, right? Like a fraction. So a rational function can be expressed as a fraction, whereas a irrational number, for example, pi is irrational because even though sometimes we approximate it as 22/7, it really isn't that. So it's a 3.1415 blah 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 blah. It doesn't have any properties where we can express that as a true fraction. E would also be an irrational number, right? Okay, so that's what we're talking about. We are talking about rational functions. So remember, a function, we had a quick review of this on Monday too. A function is when you put one in to your equation, one input, you get exactly one output. Remember, and I was calling it wrong. I was calling it the horizontal line test, but it's the vertical line test. So where you put in one x, you get out one y. So we got that going on, right? Okay, so really what we're going to be doing is we're going to be graphing these rational functions, and we're going to be talking about the domain and range. So that's kind of the important part, is to understand the domain and range. So if you have a graphing tool, go ahead and grab that out. And we'll get started here. All right, I think I have Desmos up. So the first one's a pretty easy function. It's f of x equals -4/x. Okay, so this is a rational function. It's the ratio of 4 to x. This kind of sneak peek, that particular function is a, it's what we were talking about. It's inverse variation, but we'll kind of get to that. All right, so start graphing. Here we go. All right, so we have f of x equals -4/x. So if you remember in class, at the end of the day on Monday, we kind of talked about this. When you have your x at the bottom and this negative is throwing it off a little bit if I even take my negative off, you get this curve that looks like this. So direct variation was really easy. It was a straight line. We really liked it. When you have indirect variation like this, where your x is on the denominator of your function, right? Then you get these crazy curves. So why is that? Think about this. If x is a really, really, really small number, okay? So say x is 0.1 even, right? 0.1, small number, really close to 0. Then what that does is if you divide 4 by 0.1, you actually get 40, right? It gets a really big number. If you divide it by 0.01, you will get 400. So that's why when you get really close to 0, excuse me, your y value gets exponentially bigger, right? It just grows and grows and grows up to there. Okay. Also, if you make your x a really big number, so if you make your x, you know, a million, 4 divided by a million is a really small number. So that's why if you move out your x-axis, you're getting really, really small. So that's why we don't get a straight line, because we have this inverse variation and our x's in the bottom kind of throws our curve off. Okay. Then if you look over here, when you get to the negative numbers, you kind of have this opposite relationship, right? If you put in x equals negative 0.1, you're going to get negative 40. So down here, if you put in x equals negative a million, you're going to get that y equals, you know, a really small decimal way out here. That kind of makes sense? That's the general idea of direct variation. Everybody okay with that? Hey, Anton. All right, so, but in this particular case, it's negative, which is not a big deal. It's fine. So we can graph the function. Oh, one other tip. I would also recommend for this homework to make your life easier is to print off printable graph paper. So it doesn't have to be, you could use regular graph paper. That would be easy. You can also print off, and I think I've sent this in the past, but let me know if I need to resend it. There are pages that have 6 to 8 coordinate plane graphs already with the X and Y labeled that you can put your graph on. That way it's neater for you and easier for everybody. So that's just a tip for this section. Okay. All right. So let's talk about the domain and range of this guy. That's what you guys were all hoping. Yes, I can't wait to talk about the domain and range. All right, here's my beautiful graph, right? And I need to know what is the domain and the range. So remember, your domain is your x values, right? So if I look at my x's, we'll do x's and greens. Okay, we're good on all my x's, and I get to 0, and nope, nothing going on there. And then good, right? So x is good for all real numbers except for when?
Except 0.
Yeah, exactly. So the domain would be all real except, or you could say x cannot equal 0. Okay, x cannot equal 0. Why? That's the question. Well, look at your original equation. If you put in up here that x equals 0, you get 4 divided by 0. Can you do that in math? Can we divide by 0? It's when your calculator gets mad, you get undefined. Doesn't work very well, right? So everything works except x equals 0. Okay. We would also say that, just to kind of add this in, we would also say that the x-axis is an asymptote of the graph, right? Okay, so then if I go to the range, I'll do range in purple. The range is my y's. So kind of similar situation, right? Good. When we get to y equals 0, we can't have that value. Good. So our range is also going to be all real except the x. PT, except y cannot equal 0. Okay, so why is that? So the x equals 0 makes sense, right? I put 0 in and I get undefined. Why can't I ever get y to equal 0? Well, can you tell me any x that you could put in that would make y equal 0? You can get really close, right? You could put in 4 divided by 0.00001, right? And you're going to get, oh, no, I lied. You don't want to put that in. That's going to give you a really, really big number. That's going to put you up here. That's to get to x. So instead, we could put in 4 divided by, a million. 4 divided by a million. That's going to be a really tiny number. It's going to be way out here, really tiny number, right? But it's never, ever going to actually be 0. Now, your calculator might tell you it's 0. If you do 4 divided by a Google, it's pretty close to 0. But technically, it's a tiny, tiny decimal. Still has a tiny part. Okay? So that's kind of what we're going to be doing, is graphing functions and looking at them and saying, okay, what is the domain and range? And then understanding what in my equation made the domain and range that way. Does that make sense?
Yeah.
Cool. Everybody else good? All right, cool. All right, so let's graph some more. Our next one is y equals 8 over x divided, or minus 5. 8 over x, 8 divided by x, minus 5. Right, before I graph it, you guys probably saw it anyway, but this minus 5 is outside of my function, right? This is my true function right here. The x is in here, so that's where my function is. So I have minus 5. So just think in your head, do you think that subtracting 5 is going to shift my graph up, down, left, or right? Does anybody have a guess? I'll move over my chat. Or you're like, I'm going to wait and see till you hit the view button. What do you think the minus 5 outside the function is going to do? So it's going to take your whole graph and it's going to shift it down by 5. Remember, when it's outside the function, oh, there you go, Otto. Sorry, I didn't get it in before you typed it or I saw it. Yes, it's outside the function. So when it's outside the function, that means that it's going to move it down by 5. It's going to do what it actually means, right? When it's inside the function, that's when it gets a little confusing. Yeah. Oh, there you go, Anton. Yeah. So those rules about how functions shift just keep coming up over and over again, right? Outside the function, it's going to shift it down. If it was plus 5, it would shift it up. If it was inside the function, that's where you get left and right, and those ones feel opposite. So if you subtract inside the function, it goes right, and if you subtract inside the function, it goes left. So that was a bunch of words, but basically that's what's going to happen. All right. Outside the function, negative 5 is going to shift the whole thing down. Okay. Perfect, Anton. All right. So let's really quickly, what would the domain and range be? So the domain, right, has looks like has all the values except for x cannot equal 1, right? So the domain will be all reals except, sorry, not 1, 0. The domain would be all reals except x equals 0. Okay. The range is going to be all reals except y equals negative 5. Y cannot equal negative 5. Why can y not equal negative 5? We know x can't equal 0 because 8 divided by 0 is undefined. So that's out, right? Y can't equal 0 because of that same thing again. If you even put, 8 divided by a huge number minus 5, you're still never going to get a value that is 5, or that is negative 5, excuse me. I mean, we can, make this go out pretty far and make it get pretty close. You can see you're really never going to get a value that is truly just negative 5. You can never force this to be 0. Okay, so that was kind of a quick one, but I think that makes sense. All right, so now our next one, we're going to do inside the function. So we have 1, and then we have x minus 3 plus 2. So again, what is the plus 2 going to do? Is it going to shift our graph up, down, left, or right? Yeah, everybody's got it. Up 2, right? That's good. Now, the tricky one. X minus 3 in here. What's that going to do to my graph? So we know it's going to be left or right. Is x minus 3 going to go right or left? That's right, Anton. It's going to go 3 right. Yes, because it feels intuitively wrong. You're like, I'm subtracting 3 and I'm going to the positive side. But yes, exactly, Otto and Anton. It's going to go to the right. Okay. So you'll get the hang of these really quickly. Like I said, this homework should go pretty quick for you. So just let me open this up in Paint just so I can write on it. Okay, so again, there's my graph. Okay, what is my domain? My domain is my x's. So in this case, my domain, if I look at all my x's, good, I have an asymptote here at x equals 3, right? Domain is all reals except x cannot equal 3. So this is kind of a weird math book kind of thing. You'll see it written, it kind of gets into language, right? Technically, you could also say, sometimes you'll see math books say all reals except x equals 3, because you're saying that you can have all real numbers except x cannot equal 3. And sometimes you'll say it all reals except x cannot equal 3. So sometimes you'll see this slash through equal sign and sometimes not. I honestly, on the top of my head, can't remember which way your book does it, but your book does it one way and the pre-calc book does it another way. And so it's kind of, there's not kind of a standard about that. But basically, you're conveying the idea that we know that x cannot equal 3. Again, it makes sense if you look back in your equation, because if x equaled 3, you would have 3 minus 3, which is 0. 1 divided by 0 is not allowed. So that makes sense, right? Okay, range. The range is our y's. So if I look at my y's, good. And then right here, I have an asymptote, right? So my y's are going to be all real except what? Y cannot equal 2, right? Y cannot equal 2. Again, a little bit more tricky, but whatever number I put in here for x, even if I put in 1,000,000, it's still going to be some small value that this holds. It's still going to have some value that's going to add to 2 or subtract from 2. So I can never quite get there. Okay. So in fact, I believe, don't quote me on this, but I believe that there are, I know for sure in pre-calculus. So if you're taking pre-calculus, you'll need to know this, but it might be on your standardized test too. Sometimes they could even just tell you that the asymptotes of an equation are that x cannot equal 3 and y cannot equal 2, and then you can graph based off of that it's a rational function. So you'll notice a pattern. You have your domain and your range. If you want to know what your asymptotes are, right? Your asymptotes, all right, are when x equals 3 and y equals 2. Those are your asymptotes of your equation, right? So if you would graph them on there, you get a dotted line like this and a dotted line like this. I know for sure in pre-calculus that you will take equations and they'll say graph it without a calculator by using the asymptotes of the equation. You can see how they come into play. We don't have to do that here. Here we're just learning about when we graph it, what happens. Okay, everybody's good so far? Not so bad, right? All right. But wait, there's more. All right, so now look at number 4. Now we have x on the bottom and the top. Come on, x, what are you doing? Right, we have x minus 1 on the top. Nope, minus 1 on the top, and x plus 3 on the bottom. Dun, dun, dun. All right. What's going on with this equation? Let's scoot this over a little bit here. Here's my equation. Let's talk about domain and range. Oh yes, domain and range will also be your friend this chapter. So whole lot of domain and range. Okay, so let's talk domain. All right, domain is our x's. What are our x values? Good, good, good. And you don't have to draw this every time. I'm doing just for visual, right? We have an asymptote here. And then we're good with all these values, right? So our domain is going to be all real except x cannot equal -3, right? The domains are pretty easy because the domains are usually going to be driven by your denominator. And they both start with D, isn't that nice? Your domains are driven by your denominator, right? If you have some value that you put into your denominator and you get 0 as your denominator, then that's not going to work for you. So your domains are driven by your denominator, okay? All right, so then let's talk range, all right? I want a different color. There we go. Let's talk range. Range are your y's. So if I look at my graph, I appear to have an asymptote right here for my y's, right? I'm good, good, good. Down here. So my range is going to be all real except what? X equals, or sorry, y equals y cannot equal 1. Okay, why can y not equal y not equal +1? It can get really, really, really close, but it can never equal +1, right? So where does it get really, really close? Well, when I have a really big number, it gets really close to 1. So let's see what happens if you get a really big x. What happens to your number? So let's say we have this equation, right? Take this part off. Okay, so let's put in a big number for x. 1,000 and 1,000. Okay, so I have 1,000 minus 1, so I have 999 divided by 1,003, right? My result of that is really close to 1, but it's never going to quite get to 1. You're always going to have some difference between the numbers that's going to lead you to have a a number that is really close to 1, basically a fraction that's really close to 1. Even if you go out a couple more decimal places, right, you're going to get really close to 1, but you're never going to quite get there. Again, if you put in your calculator a big enough number, eventually your calculator will approximate it at 1. Technically, it's not 1 yet, right? There's still always one little part. Okay? Make sense? Cool. We like easy sections on when we start, right? Let's do the last two. We might just talk about them. Maybe I'll have you guys tell me in the chat, what do you think it is? All right, so we've got number 5 is y equals 2x plus 1 divided by 4x minus 2. This is where if you are using your TI calculator, just be really careful about how you plug this in. So what I mean by that is in your TI, you're gonna wanna put parentheses around the 2x plus 1 and around the 4x minus 2, because if you don't, then your calculator is gonna think that you're doing a different function. Hopefully that makes sense. So yeah, just make sure that if you have your TI that you're getting, I always like to say in your TI, you can always over parenthesize. There's nothing wrong with extra parentheses as long as you're closing them in the right appropriately. But it's never an issue to have too many, basically. If you have an extra parenthesis, it still will know what to do. But if you don't have parentheses in the right spot, then it's going to get confused. Okay, so this one is a little bit more tricky. If you look at the graph, the other ones were nice whole numbers. And here it's a little bit harder to see where your asymptotes of the equation are. So one option is that you can go out here and see what number it looks like. Well, first let's look at our x's, okay? So if I go for my x values, we're good, we're good, we're good. I'm looking at my x value, here. Okay, so as I scroll out here and get bigger and bigger, it looks like my x value is getting, if I scroll further, really close to it's getting 0.485. Okay, and then if I go on the other side, it's 0.545. So I'm going to guess that my x value has an asymptote at 0.5. Right? That's what I'm going to guess. Algebraically, how could I verify that? Like, I can just look at my picture and it looks like it's 1/2, right? All right, so I'm talking about my x values right now. I'm talking domain, right? Excuse me. I'm talking domain. So good, 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 right? Has some value here that I'm guessing is 0.5. Good, 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 good. So remember, the domain has to do with the denominator and where it equals 0. So when does this denominator equal 0? Well, it's when 4x minus 2 equals 0, which is when 4x equals 2, or x equals 2 over 4, which happens to be 0.5. Okay, so sometimes when you graph it, you can't get a great picture. It's not super straightforward, but you can still use this fact that your domain depends on your denominator when it equals 0, and that will help you figure out where your domain and range are. So the domain is going to be all real except x cannot equal 0.5. Okay. We didn't explicitly talk about this, but let's look at the range. Okay, first let's look at our graph. Okay, if I was trying to determine this on my graph, I have some like value that it gets down to, but never quite gets to. So way out here if I look at, now I'm looking at my, now I'm looking at my y values. So way out here, I get to 0.487, right? And then if I go on this side, I get to 0.508. So what do you think the y value that it can't be is? The y value looks like it's also getting really, really close to 1/2, right? Yes, no, maybe. Yeah, okay. So the y value is, it's all real except y cannot equal also 1/2. Okay, so why is that? Why can that not equal 1/2? So this is kind of a weird example that they ended up being 1/2. It's not always true that that's the case. Okay, and the next one that we'll do, I'll show you why. It actually has to do with these two numbers here. Okay, so your 2x over your 4x, if you look at those values and you kind of strip away the x, that's going to tell you that it can never be 1/2. So I actually want to show you in the next one what that looks like. Okay. All right, so let's do the last one on here. Dun, dun, dun. All right, so the last one is f of x equals, and again, I'm going to put it in parentheses, negative 3x plus 2 divided by negative x minus 1. Okay, so again, I am going to try to find my domain and my range, right? Oh, another way you could do this if you're on your graphing calculator is you could kind of type it in here to see how it looks. So let's start with domain. Domain is your x's, right? Good, 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 good. Somewhere in a negative value over here, we have a value that's not true, and then we're good over here. So when does negative x minus 1 equal 0? So if you put in to this, and I don't think it lets you do this. It doesn't like that. There's some way you can put it in x equals negative 1. No. All right, so if I put in x equals negative 1 here, I get negative negative 1, which is positive 1, minus 1, which equals 0. Okay, so actually I have an asymptote of the graph when x equals negative 1. So can you see how I drew that asymptote in there? And I think, no, I thought there was some ways to make it dotted. I forget how to do that. Anyway, yes, there you go. That's the asymptote. So the domain is going to be all real numbers except when x equals negative 1. Right? That doesn't work. What about your range, your y's? So all good until we get to this value right here. So this value, when I go out this way, it looks like it's getting closer and closer to 3. And this value here looks like it's getting closer and closer and closer to 3. Okay, so I actually have a y asymptote when y equals positive 3. That's my y asymptote. Okay, so can you see, I don't like the color on this. There we go. That's much better. Okay, so the blue is my my vertical asymptote and the red is my horizontal asymptote. And those also tell me the values that my equation cannot be. All right, so can you see they don't always match up. In the last example, they both were 1/2, so that wasn't a perfect example. And this one, they have different ones. So where did my x value come from for my range? Or for my domain? For my domain, right, I said, when does negative x minus 1 equal 0? And it is when, if I add x to both sides, it's when x equals -1. So that's how I came up with, x basically cannot equal -1. All right. So the part I didn't tell you is, where does your y value come from for your range? So the y value from your range actually comes from when you look at these two values here. So you look at your x values, and this is, yeah, so if you have -3x minus x, you kind of ignore this, these two over here. If you pull those out, then you get -3 over -1, which is just 3. So y equals 3 is going to be your y asymptote, or your horizontal asymptote, and your range is going to be every value except y equals 3. So that's where that 3 comes from, in case you want to do it algebraically. Okay. Super exciting, right? No, I think it's actually pretty cool. I really like graphing rational functions. I think they make sense. You're like, oh, okay, I got this. But wait, there's more. We won't have time to finish this other section. If you want to do your homework, because I haven't handed out to you, 8.2 is 3 through 21 odd. Again, I would really, 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 really recommend printing out some printable coordinate planes. So you can even, I'm going to be risky and go here. If you just search printable coordinate planes, you can do 4 on a thing, there's 6 on a thing. So you can print any of these off, and then you're not graphing over and over again, right? Or you're not drawing your graph over and over again. So there's plenty out there that are free that you can download. I think I sent some out too. All right. No, I don't want to leave the site because I want to leave Desmos up. All right, Anton was going to tell me how to do it. Try clicking the line image besides the function, then you can dash it. I knew there was a way to do that, Anton. Let's see. The line function. All right. Try clicking the line image. Right clicking. That's what I was trying to do. I thought that I could do that, but it wants to open, like, it wants to do, I know. I feel like it's worked. I don't know if maybe, Anton, it's because I'm on like recording it with YouTube and it's something else that it thinks I'm trying to do. Hold it down longer. Ah, there we go. Here, if I left click and hold it down longer, then I get it. There we go. Thanks, Anton. It's like, I knew there was a way to do it. There we go. So now we've got our nice asymptotes. Thank you, Anton. And there's our graphs with our asymptotes. Thank you. All right. I'll have to remember that. Okay, so that was 8.2, which is graph simple rational functions. And 8.3 is graph general rational functions. So those were simple because if you noticed in all of the ones that we graphed, not to kind of scroll crazy for you guys, but all of these, they just had x and the numerator and denominator no fancy exponents or anything, right? So we're not going to be afraid of exponents. We're going to graph general rational functions, and we're going to be able to do the same thing, right? So now, if you notice number 1, it has 4 divided by x squared plus 2. So we get a little extra bit of fun in there, right? So we get, let's see what this guy looks like. 4 divided by x squared plus 2. Look at this fun function. So x squared plus 2, by the way, is what kind of equation is that? X squared plus 2. It's a quadratic, right? If I just do x squared plus 2, you get your nice quadratic equation, right? But we're dividing by a quadratic equation. So look what it did to our graph. Our poor graph, it's like bloop. So you can get some pretty cool equations by by dividing by quadratics. Pretty neat looking, right? All right, so let's look at this equation and let's talk about what the domain and the range would be. So your domain is controlled by your denominator, right? So the domain of this is what x's are true. So in this case, I look like I'm good for all my x's. They all look good, right? Doesn't look like there's any that are left out. Why is that? Well, if I look algebraically and say x squared plus 2, when does that equal 0? Right? I get x squared equals negative 2. And if I do that, I get x equals plus or minus the square root of negative 2. What do we know about taking the square root of negative 2? It's imaginary, right? It's on the imaginary plane. It's not a real number. So because the way to get x, the denominator equal to 0 is in the imaginary scale, then that means that our domain is going to be all real numbers. So that's pretty good. We like that, right? Okay. What about our range? Our range is a little bit more tricky. We might actually have to move back to regular Desmos. So our range looks good for all values. And then we get here to, or no, sorry, I'm totally drawing that wrong. Our range isn't all those values. Or back up. Our range is good from here to here. Right? Our range really is a very short window. So I know for sure that our y values, our range, right, is somewhere in between. Y has to be bigger than 0, but less than 2. Somewhere in that value. I know that that's where my y is going to end up being. The question is it able to be equal to 2 or equal to 0, or it just has to be greater than or less than 2 and 0? That's the question. Okay, so we need to look at this at a couple different values to figure that out. So I'm good with this top range. What I'm trying to figure out is if it can actually be equal to these values or not. Okay, so the first thing let's figure out is, can y ever actually equal 2? Can y actually equal 2? Okay, so as you can see, this is when x equals 0. What happens to my equation? Well, when x equals 0, I get 4 divided by 0 squared plus 2, which is the same as 4 divided by 2. It's 2. So that confirms to me that this is true, that y has to be less than or equal to 2. So I'm good with that, right? Then I got to look on the other side. I need to pick a value that's way out here. When I go way out here, it looks like it's getting really close to 0. So what happens when x equals, let's just say, 1,000,000? Or we can just go 10,000 even. So if I have 4 divided by 10,000 squared plus 2, it's going to be a huge number on the bottom, right? Does that ever technically equal 0? It does not, right? Because they're always going to have some tiny fraction. So on this side, I don't need the equals part. So for my range, y is going to be greater than 0, but less than or equal to 2. That's what my range would be for this particular function. Okay? So, yes. So that's what's going to go on with that. It is almost time to be done, but I do want to show you that your equations aren't always going to look like this. It's going to look like this if your quadratic, basically if the number of your exponent is bigger in the denominator than the numerator, then it's going to look like this. But what happens, and this isn't even in one of your examples, but what happens if I throw a quadratic on the top? So then you kind of have the quadratics competing against each other. So you get a little bit different value. And then what happens if I have a quadratic on the top and a linear on the bottom? Then you're going to get some other kinds of crazy equations. So it's not always going to look like that. It just depends on kind of what's on the top and the bottom. So we will pick up there on Monday. We'll go back to 8.1 because that's more algebra based. And we'll probably pick back up on 8.3 and talk about that. And yeah, keep going from there. So I will have notes printed out for you guys on Monday. Again, if you would like to start working on 8.2, if you have a little extra time, it's 8.2 3 through 21 odd. So if you want to do that, that's what's going on with that. Oops, sorry. If not, get your chapter 7 stuff all done. It's due on Monday, so that way we can kind of move forward on 8. I think it's I think you guys are going to like this section. So so that's it. Thank you guys all for coming today. Have a great day. Enjoy the rainy day. And I'll talk to you later. Bye, guys.